Welcome back. In this video, we're going to look at static equilibrium. If something's static, it's not moving. And so if you have forces pushing on something, it's going to move unless there's force acting in the other direction that's keeping it from moving. So if you have two strong men playing arm wrestling and they're both pushing with huge force, their hand won't move. It'll just stay there trembling as it goes back and forth because the forces are balanced. So anytime forces are balanced, you've got something not moving. Anytime that forces are not balanced, you've got something moving because force causes movement. So if a chair is sitting on the floor and not moving, the reason why that it is not moving is because the force of gravity that's pushing the chair towards the floor is countered by the floor pushing back up onto the chair, and so the forces are balanced and it doesn't work, or it doesn't move. If the chair becomes 20 quadrillion pounds, it'll actually fall right through the floor because the push from the floor will not be enough to keep it from falling. Okay, so right now force is in newtons, and it says here that little Nellie Newton wishes to be a gymnast. Okay, so she has a weight of 300 newtons. Now we weigh ourselves in pounds, but if you take kilograms and multiply it by the force of gravity, you're going to get what the force is that's actually pushing you down, and that is newtons. So she weighs 300 newtons. We could convert that into kilograms and then eventually into pounds so we would know what she weighs, but in physics we use newton as the unit of force. So if she has a ring and then you've got a newton scale here to find what the tension in that string is, that's the force that she's exerting on that string, all 300 newtons would be on that one string. If she has a 300 newton weight but she is breaking it into two strings, I think you could guess that half of her weight is being supported by the first string and the other by the second string, and both of those together would add up to be 300 newtons. So she is going to have just this one here would be 150 newtons. If she is suspended by three, you take the 300 newton weight and divide it by those three strands, and you would have 100 newtons each. Okay. Now here's one that maybe is not as easy to figure out. What is the tension? She is pulling on this string and making it tight. What is the tension in the string? Well, she's pushing down at 300 newtons. So anywhere on that string, you're going to get a 300 newton force. So if you have a spring scale here, it's going to show that there's a 300 newton force on that string. If you have a spring scale here, it will also show that you have a 300 newton force, because anywhere on that string, 300 newtons is being exerted. That tension on a string is the force being pushed down on it, and the string has to counterbalance that by being strong enough to hold her, otherwise the string will break if it's not. Now this is kind of weird. I don't know if you could guess this or not. If she's holding herself on a cliff edge or a building, and then she's suspended on the other one, what do you think is going to happen? Okay, this would be like standing on the scale with your right foot and standing on the floor with your left foot. Would you weigh the same or would you weigh less? Okay. What's going to happen is that she has her weight on her right hand and her left hand, and both of those hands have equal amounts of weight. So she's going to have half of her weight is being supported by her right, half of her by her left, and so this cliff or this building is supporting half of it, or 150 newtons, and then she is supported with the other three. Okay. Now this looks crazy with all these pulleys. A pulley doesn't help you at all. A pulley is just redirecting the force. If you go across this pulley, this has how much force? If she weighs 300 newtons, what's your guess? It's still the same as if this were hanging from the ceiling. This will be a 300 newton. Even though it's hanging from the floor, it's still redirected around, and so the tension in this string is the tension of her weight. So it's a 300 newtons there. Okay. So Burl, the painter, stands in the exact middle of the staging. The left scale reads 600 newtons. Okay, 600 newtons. Fill in the reading of the right scale and the total weight that he must have. Okay. do you see that there's two strands holding it exactly? And if one is, he's in the center, and one of it is 600, okay, then the other is going to be also 600. I wonder if you guessed that, okay? So what does he weigh in newtons? If it's 600 and 600 to hold up his weight, we're imagining that he's standing on a a scale that doesn't weigh, or a board that doesn't weigh anything, which is crazy. But if this is just Burl we're talking about, that's going to be a total of 1,200 newtons that he weighs. He weighs more than Nellie. Now, what's going to happen here? If this is 400 newtons and he weighs a total of 12, okay? So 4 plus 8 is 12. Then if he's closer to this, the reading here is going to be tighter. Okay, you're going to put more of your weight on this string, less of your weight on this string. So if he weighs a total of 1,200, this must be something plus 400 equals 12, which is 800 newtons. Okay. Now, if he's on the very end and this weighs nothing, so like he's supporting himself just on this strand, and this is actually wiggling so that there's no tension at all in this strand, then all 1,200 newtons must be hanging from this one suspension. Okay. So this is called the equilibrium rule, and the equilibrium rule is all things will add up to 0. Okay. Let's see if we can do any more. Okay. Manuel weighs 1,000 newtons and stands in the middle of a board that weighs 200 newtons. So now we're going to have 200 plus 1,000. So both of these are going to be together 1,200. And he's right in the middle. So what's your guess? Okay, talk among yourselves. This is going to be, and this is going to be. I would say it's going to be 600, and this is 600. Because 12 and 2 is, or 1,002 is 1,200, and then you're going to divide that by 2. Okay. Manuel is the same guy, so he's still going to weigh 1,000. This is still 1,200. Now, so 1,200 down and 1,200 up. If he is not moving, if that board is not collapsing, then the same amount of force is pushing up as is pushing down. So if you've got 12 pushing down, you've got to have 12 pushing up. So 12 minus 8 is 400, and 850, this would be 350. So if he's closer to this one side, his weight is pushing down more on this side, less is being pushed on this side. Okay, so this is how bridges work, by the way. You're going to have force pushed up by the mountain as the road is pushing down. Otherwise, the road would fall into the gorge. So a 12-ton truck is 1/4 of the way across the bridge. Okay. 1/4 of the way across the bridge. So the road weighs 20 tons and the truck is 12 tons. Okay. So how many tons is going down? You've got 20 plus 12 is 32. There's 32 tons pushing down. Well, that means if it's not moving, there must be 32 tons pushing up. Okay. So if there's 32 tons pushing up, 13 of it's on this side. How much is on this side? Okay, so if I take 32 and I subtract 13, I'm going to get 19. 19 will be how much that's left over. Okay. 1,000 Newton crate, remember Newton is the force that it's exerting pushing down. It's its weight, Newton's are its weight, is resting on a surface connected to a 500 Newton block. So this iron block is 500 Newtons. Okay, its weight is 500 Newtons. And this is pushing down at 1,000, okay? And we're going to see that if it's not falling into the floor, there must be 1,000 pushing up on it, or else it would fall into the floor. So that's called the normal force. The weight is pushing down into the floor, and the normal force is the force that's pushing up, just like the floor is pushing up on the chair. So it's going to be equal to its weight, so that's 1,000 newtons, okay? And it says friction, a frictionless pulley, friction between the crate and the surface is enough to keep the system at rest. Okay, so the friction is working back at the same as the tension is moving forward because it's not moving. So the tension's moving forward, and friction is moving back. And so as soon as we know with the tension, we'll know the friction because they're going to be equal to each other. Well, this tension is the same as this tension. What's causing this pull? It's the weight that's being tugged on that string. So we need to find out what this weighs. Well, that means the weight is 500 newtons. So how much force is now in the string? The same force that's pushing down, so this is 500 newtons. Well, what's this force? That's the tension in this string. Well, the same tension because it's still pulling the same, so that means the tension in this string is 500. And if it's not moving, then that must be that there's 500 newtons of friction. And if the normal force, I should have written that first, its weight was 1,000 newtons. And its normal force, or the force exerted by the table, is also 1,000 newtons. Okay. All right, we'll cut that one. Hope you understood that somewhat. Thank you.